Okay, so the diagram has got object A here showing a mass of 15 kilograms suspended in equilibrium in a shaft with the vertical walls. So you have the walls by means of two ropes. So these are my ropes here, X, Y and XZ, okay, holding on to this mass. So we've got a balance, and of course all the forces here are vertical, in the vertical plane. Now, when it comes down to calculating the tension in each of the ropes X, Y and XZ, we need to consider the fact that there's a tension here, okay, in the rope XY, and maybe we can call that T1, and then there's a tension here in the rope XZ, maybe we can call that T2, and it's balancing, yeah, the weight of this object, okay, because it's 15 kilograms, 15g, okay, will be the weight. Now, situation then is we need to draw a cross, yeah, for the components of each force resolved in the vertical and horizontal direction, okay, as always. Now, the easy force here to put in place is the 15g here, because we know that's going downwards, okay. We then need to consider the T1 and T2 resolved, okay, because they're going at an angle. We need to see them resolved in the horizontal and vertical directions, okay, to see the component that's going across and the component that's going up of this force. Now, the issue we've got here is that the angles are over here, okay, the angles 45 degrees, 60 degrees. We need them to be here at the point, okay, the center point here of our forces, okay, where the forces are working away from. So what we can do is just do a bit of geometry. If I draw a line here, okay, vertical line, let's just do maybe a broken line, okay, and we can play around with the angles. We can appreciate that we've got here a Z angle, okay, so we've got, if you notice here, a Z being formed, okay, so we can see then if this is 60 degrees, so also must this be 60 degrees, okay, and then similarly then if that's 45 degrees, so also must this be 45 degrees, because again we've got another Z angle, okay. So we've got T2 here being 60 degrees, okay, to the vertical, and T1 being 45 degrees to the vertical. So if we resolve T1 to the vertical with this angle here contained, T1 cos 45, and then it'll be the opposite then, T1 sine 45 here, and then the T2 will be T2 cos 60 to this side, and then opposite then will be T2 sine 60 here. And quite simply then, when we resolve forces, because they're in equilibrium, we can say that resolving across, we can say that T2 sine 60 is equal to T1 sine 45. Now the good thing is sine 60 is a nice-ish value. On your calculator you get root 3 upon 2, and sine 45 is also a nice value. You get root 2 upon 2 T1. So then you've got this situation, so then the 2's will cancel. We can multiply through by 2, so we've got root 3 T2 is equal to root 2 T1. If we resolve then vertically, okay, we've got then these two forces combined, so we've got T1 cos 45 plus T2 cos 60. That will equal to then the weight down here, which is 15g, okay. Again, we can use our calculator here, so cos 45 will be root 2 upon 2, T1, cos 60 is a half, T2, and 15g there. Multiply through then by 2 to get rid of these halves, so you got root 2 T1 plus T2 is equal to 30g, yeah, because I'm timesing through by 2. Now, what you'll hopefully notice then is, with the equation 1 here, and equation 2, you can sub in equation 1 into 2, okay, so we can say, look, sub 1 into 2, because if you notice, root 2 T1 is what we've got here, and we know now that root 2 T1 is actually equal to root 3 T2, okay. So I'm working on this equation and I'm replacing this with what it's equal to from equation 1. So instead of writing this now, I can write root 3 T2, add then T2 here, and then that equals to 30G. And then we've got a situation where we can work out T2, because we've got a simple equation with just T2 involved. Now what I would do now is factorize out T2, because it's common here, factor, and of course you've got to times it by root 3 to get this, and then you've got to times it by 1 just to get T2, 30G. And then just to finish off then for T2, you just need to do 30G, well that's 30 times 9.8 upon then root 3 plus 1. So we can work out our T2 on our calculator. So if I type that in, so we've got 30 times 9.8 over root 3 plus 1, and that comes out to be 107.611 newtons. And then we just sub that answer then into 1. Okay, so sub into 1. We'll have root 3 times 107.611 equals to root T2 T1. So then T1 will be root 3 times 107.611 divided by root 2. So on my calculator, I can type in fraction, I can type in root fraction, so root 3 times ants over root 2. And I get it out to be 131.797 newtons.